Hello, it's Mr. Cruz, and this is your flipped classroom lesson on the periodic table. And so who you're looking at now is Mendeleev, and he was the scientist that actually came up with the first periodic table. He was a Russian scientist, and you can see it's his notes are right here. This is actual like a image of some of his notes from the first periodic table, and this is what it looked like when it was published. And you can see it looks much different than the modern day periodic table that we're going to become familiar with. But the word periodic means patterns, and so Mendeleev noticed that there were some patterns in the elements. He noticed first that the atomic mass increased in the elements. So here you have hydrogen, which has an atomic mass of 1, and then he discovered beryllium, 9.4, boron 11, carbon 12, nitrogen 14, and so on. So you can see that this was clearly a pattern, and he discovered this. And that what was interesting was he even predicted that there might have been some elements yet that had not been discovered, like these elements here with the question marks. He said, I think there's some elements here that exist that haven't yet been discovered, and he was actually right. So he arranged his table according to increasing atomic mass, and he also noticed that the way these elements behaved when they reacted with other chemicals was in a repeating pattern. And you'll see that, I'll show that to you on the modern periodic table, and you can see how that works. So this is the first periodic table. Now this is the modern day periodic table, and you can see that it looks very different from the original periodic table, but there are also a lot of similarities. First of all, you can see that the table is set up in columns and in rows. So a column goes up and down, vertical, and a row is horizontal. And that's important to distinguish the difference between those two. Now, you're never going to have to memorize this table, but you are going to have to understand how it's arranged and how it's organized and set up, and that can really help you out with many things. First of all, you can see that the atomic number is one way that the table is patterned. You can see here hydrogen has an atomic number of 1. There's the 1. And then you go over to helium, atomic number 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, and so on. So you can easily find an element, say what is atomic number 50, and you can see, oh, that's Sn, which is 10. So it's easy to find the elements as long as you know their atomic number, and they are in atomic number order. Another pattern you see is that the atomic mass, which is the bottom number, increases as you go from left to right. So the elements get heavier if you go across a row, and they also get heavier if you go down a row. So you can see hydrogen has a mass of 1, helium 4, lithium 7, beryllium 9, boron 11, carbon 12, nitrogen 14, oxygen 16, and so on. That's the same pattern that Mendeleev saw. So the other things, we need to learn what the columns represent. A column is vertical, and these are called groups or families. And what makes that unique is that the elements that are in the same family have similar chemical traits, just like a regular family might have similar traits. For example, maybe there's a family and they all have freckles, or all of them are short or tall. A lot of times in families, because of genetics, you see similarities in the brothers and sisters and in the parents and the kids. And I want you to think that with elements it's the same thing. For example, lithium, sodium, and potassium all react with water in the same way. If you put a drop of lithium, a little piece of lithium, which is a soft metal, in water, it will actually catch on fire. Sodium will as well. Now this is different from sodium that you're thinking of, table salt. This is the element sodium. It's actually a metal that's really soft that you can cut with a knife, actually. And if you drop it in water, it will catch on fire. Potassium, the same thing. So they have similar chemical properties And that's what makes a group or a family unique. Now, the horizontal rows are called periods. So we have period 1, period 2, and you can see period 1 only has 2 elements. Period 1 has hydrogen and helium. Period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. And if you actually, this tells you a lot here. Period number 1, going across, has 1 energy level. So hydrogen has 1 energy level, and helium has 1 energy level. If you go to period number 2, that's lithium, beryllium, boron, carbon, and so on. These elements all have 2 energy levels. And this makes sense because the first energy level can hold 2 electrons. So there's only 2 elements in that first energy level, in that first period. And then when you get to lithium, you get that second energy level that starts to fill up. And then when you get to neon, that second energy level is full. And look at its atomic number. Its atomic number is 10. That means there's 2 electrons in the first energy level, 8 in the second energy level, and then that energy level is full. And then you get to the third period, where you have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. And their energy level, this is where the rules get a little different. It's not full at 18 with 18 electrons, but it does have 8 electrons in that third energy level, and then the fourth one begins to fill up. So the rules kind of get a little different as you go deeper in the table, but you can know that whatever period that the element is in, you know exactly how many energy levels it has. So I could say, how many energy levels does copper have? And you'd say, okay, well, it's in the 4th period, so it must have 4 energy levels. And of course it has 29 protons and electrons, and its mass is 63. So the periods and the families can tell you quite a bit. Now the last thing that's really important is what we call valence electrons. And a valence electron is the number of electrons in the outermost energy level. And this is very important when it comes to bonding. And it's a simple pattern. Family 1 has 1 valence electron. So that means hydrogen, lithium, sodium, potassium, rubidium, and so on all have 1 electron in their outer shell. All their other shells are considered full. The inner shells are full, and their outer shell has only 1 electron. And here the pattern continues. This family has 2 electrons in the outer shell. Now this middle group, this is called the transition metals, and they do lots of strange things. So that's where the pattern sort of is broken. But if you go over to here, boron has 3 electrons in the outer shell. Carbon has 4 electrons in the outer shell. Nitrogen has 5 electrons in the outer shell. All of the elements, actually, I'm naming the top element, and so oxygen, the whole group here, has 6 electrons in the outer shell, and fluorine, chlorine, and bromine, and so on, has 7 electrons in the outer shell. And these guys here are called the noble gases, and they have a full outer energy level. So helium has 2 electrons in its first shell, and it's full. Neon has 10 electrons, 2 in the first, 8 in the second, so its outer energy level is full. And that's the case for all of these. Their outer energy levels are full, and they're called the noble gases. They actually don't react with other elements at all chemically because their outer energy level is full. So that's a walk through the periodic table. There's still more to come, so just hang tight. Let's revisit some of the boxes here, and I want to make sure that you understand that the atomic number is the top number, and that tells us the number of protons and electrons, and the atomic mass here is the bottom number, and you round that off, so this would be rounded to 11. atomic mass units, and that's the number of protons plus neutrons. So make sure you know that. That's very important to help diagram an atom and understand the structure of the atom. Let's move on again. I need to show you how the periodic table is arranged into metals, nonmetals, and metalloids. Alright, so here we are back at the modern periodic table again, and I want to draw a stair step right here in red. And this is important. You're going to have to know where this stair step is. If I give you a quiz, you're going to have to know it starts at boron and goes down, and then it's just a natural stair step all the way between these two elements here, 84 and 85. Now why that's important is because it's a dividing line. All the elements that are on this side, on the left of the stair step, are classified as metals. Metals are typically shiny, they conduct electricity, and they conduct heat well. And those are some common characteristics. You have copper, nickel, oops, that's cobalt, nickel, copper, zinc, lithium. Sodium is actually considered a metal just because of the way they behave chemically. You might not think of sodium as a metal. You're thinking of salt, NaCl, but that's a compound. The only exception is hydrogen. Hydrogen is a nonmetal, and the nonmetals are on the right side of the stair step. So all these are nonmetals. A lot of them are gases at room temperature, or liquids at room temperature. They don't conduct electricity well. They're not good conductors of heat. So metals and nonmetals are sort of opposites. And hydrogen is over here because it belongs in family 1 or group 1 because it has that one electron on the outer shell. So it behaves like a metal chemically, the way it bonds and reacts with other things, but its properties are a nonmetal because it's a gas, obviously, at room temperature. So then there's the metalloids, and that is the elements that border the stair step like this, except for aluminum is an exception. Aluminum's not a metalloid, but these metalloids are elements that behave kind of like metals and kind of like non-metals. They're sort of the in-betweeners. And it makes sense that they're on the dividing line, which is the stair step. So, they might be good conductors of heat, but have low melting points, So they have traits of both metals and non-metals, and those are called metalloids. So on a quiz, you might have to know, that most of the table is made up of metals on the left, and that the non-metals are on the right, and you'll have to know the traits or characteristics of metals and non-metals, and you'll know that the stair step is where the metalloids are, and it's sort of the dividing line. So this is the modern periodic table, and I want you to know that there's going to be a quiz tomorrow on diagramming an atom. So if you listen to this whole thing, you have that as a hint, and you can study to prepare for that. And I will see you tomorrow in class. Bye-bye.